right, let's start off today's lesson. The first thing I want to go through is a quick recap of an introduction from last week. So, recap that if you have a triangle and this is your angle, this side is your opposite side, this side is your adjacent side, and that side over there is your hypotenuse, part of trigonometry. We also know that if you calculate sine of this angle theta, we always take the opposite side length and divide it by the hypotenuse length. We then take cosine to be the adjacent side length over the hypotenuse length, and then tan theta to be equal to the opposite side over the adjacent side as well, like that. All right, so recapping that, we got sine, and this is SOH, so that's where SO comes from. This is CAH, that's where car comes from. And then TOA, and that's where torque comes from. So basically, looking at this here, we could apply this to an example. If I have a triangle, and I know that this is my angle here, theta, I know that this side is given to me as, let's say, 4 centimeters, 3 centimeters, and 5 centimeters, and we can use Pythagoras theorem to work out any missing side. I can see that sine of theta, which is opposite over hypotenuse, will be equal to 4 over 5. While cos of theta, which is equal to adjacent over hypotenuse, will be 3 over 5. While tan theta, which is opposite over adjacent, will be 4 over 3. And so I can calculate each of those like that. Keeping that in mind, I'm just going to make it a little smaller. If I give you a triangle, I want you to get me sine, cos, and tan for this specific triangle. So let's say this is 9 meters, 12 meters, and 15 meters. See if you can get the ratio for sine, cos, and tan for this. Give it a go. Try it, and then as soon as you're done, I'll go through it. So in this example here, we first label the sides. So because this angle is here, this side becomes my opposite. This side becomes my adjacent. And because this is the 90 degrees, look over that side, the opposite direction of the 90, you'll see that will be your hypotenuse. So sine is opposite over hypotenuse, so it's 9 over 15. Cos is adjacent over hypotenuse, it'll be 12 over 15. So you always use the numbers that they gave you, or that you worked out. And tan is equal to opposite over adjacent, so 9 over 12. All right, let's look at an example like this now. I give you a triangle, and I tell you that this side here is, let's say, 12 meters, and this side here is 20 meters, or let's make it 30 meters. I don't know what x is, and I'm told that the angle over here is just theta. The first thing I want to do is I want to find the question, let's say, says find the ratio of sine, cos, and tan. And then the next question, calculate theta, the angle. So in order to do this question, the first thing I need to do is I need to calculate x. So let's go ahead and let's find x. To find x, we use Pythagoras theorem because we know two sides. So therefore, we'll have x squared plus 12 squared equals 30 squared. X squared plus 144 equals 900. X squared equals 900 minus 144. Square rooting both sides gets me square root of 900. Grab your calculator. Square root of 900 minus 144 comes to 27.5 to three significant figures. So x is equal to 27.5 meters. Alright, using that now, I can label the sides. This is opposite, this is adjacent, and this is hypotenuse. Now, with that, each of these have a certain ratio of each of those sides. So sine, remember, is so. Opposite over hypotenuse. Cos is car. Adjacent over hypotenuse. Tan is 12. Opposite over adjacent. So therefore, if I go sine of the angle theta, it will equal 12 over 30. Cos of the angle will equal 27.5 over 30 because it's adjacent to the hypotenuse, AH. And tan of theta will equal 12 over 27.5. And that answers the first question. So the next question now, question number 2, it says calculate theta, the angle. To calculate the angle, we can use any one of those. We can use sine, we can use cosine, or we can use tangent. We can use any one of those. If I use sine, which is equal to, let's say, 12 over 30, it'll give me the same answer as cos. All I have to do is move the sine across to the other side, and on my calculator, press shift first, then sine, 12 over 30. So shift sine, fraction button 12 over 30 will come to 23.6 degrees. So this angle here is 23.6 degrees. How did I do that? I wrote this again, and I simply just moved the sine over to the other side. And when I find any angle, I always use the shift button. So I press shift on my calculator. Then I press the sine button, and then I put the fraction in just like that. Press equals, and it shoots out the answer 23.6. Alright, I'll give you a second to think about it, and then we'll go through an example. In the next example now, we're going to do exactly the same thing. So you're going to use Pythagoras theorem, and then you can use sine, cos, or tan, or you can just try and find the angle immediately. In this question, I just want you to find theta. I'm going to give you two sides. The side at the bottom is going to be 30 meters, and this side length there is going to be 40 meters, let's say. So if I want to find theta, the first thing I need to decide is label my sides. This one is my opposite. This side is my adjacent. And there's the 90, so this is my hypotenuse. The longest side is your hypotenuse. I can see that I have the adjacent and I have the hypotenuse, but I don't have the opposite side. So I can use Pythagoras theorem to find it if I want to use it. But if I don't, I can save some time and use the adjacent hypotenuse. Now remember, SOL requires opposite and hypotenuse. I don't have the opposite, I have hypotenuse. CAR requires adjacent and hypotenuse. I have both. And TUA requires opposite as well, so I don't have that, but I have the adjacent. So from these, I can definitely use CAR right now. What does that mean? It means that I can write cos theta, that's what C stands for, equals adjacent over hypotenuse, which is equal to 30 over 40. So you write the ratio, right? So step one, you write it out like this. Because you're finding the angle, you're going to move cos across. So theta is going to become cos, shift cos 30 divided by 40. And so shift cos 30 divided by 40 equals 41.4 degrees. So I definitely use cos because it's got adjacent and hypotenuse in there. Now you can use sine, you can use tan as well, depending on what you have. Depending on whatever you have, I'm going to make this a little smaller. And let's say we try another example. You try this one. I've got a triangle. I'm going to give you two sides and I want you to find the angle. It's a right angle triangle. Find the angle if this side is 12 centimeters and this is 18 centimeters. See if you can find theta. All right. Step one is actually choosing. Step two is writing it. And step three, putting it in your calculator and pressing shift. Calculator, write the function, choose the function. All right, give it a go. Try it. Let's have a look. Okay, cool. So from this one here, we've got to decide if we're going to use sine, cos, or tan. So between SO, CAR, and TOA, I know I have opposite, and I also have hypotenuse. So this is going to be the one I'm going to use. So I'm going to write sine theta equals 12 over 18. Now take the sign across, and on your calculator, press shift, then press sign, then press the fraction button or put the fraction in, and then press equals. Shift sign, fraction button, 12 over 18 equals 41.8 degrees. Make sure your calculator is in degrees mode. It must have a little bit of a D at the top. Okay. All right, let's try now another one. In this example, I am going to give you the angle to be 25 degrees, and I'm going to tell you this side is 12 meters, but I want you to find x. We start with the same part. We say SO, CAR, and TOA. We've got to decide which one to use. So we've got opposite, and we don't know the adjacent, but we're still going to take it off. So I've got an unknown adjacent, and I've got an unknown opposite, so I'm going to use tan. So let's write it out. Tan of the angle I know now equals first O over A, so 12 over x. I need to now solve for x. Because x is in the denominator, I can multiply both sides by x. First, to cancel it, then divide both sides by tan 25. leaving me with x equals 12 divided by 10, 25 degrees. Put it on a calculator. Now you press the fraction button, then you punch it in, and you press equals. No shift required for this, just 10, 25 degrees. So 12 over plus 10, 25, close the bracket, which it'll come into a bracket like that. Then press equals, comes to 32.9. Round it up, 33 meters. All right, keeping that in mind, make it a little bit more readable. I want you to try the next example. Step 1, don't forget, choose the correct one. Step 2, write it down. And step 3, simplify to get x. Okay, so here's another triangle. I'm telling you this is 20 degrees. This is x. And this over here is, let's say, 17 centimeters. Find x. Calculate x. Here we go. All right, let's go through this one now. The first thing to remember is identifying. Are we going to use saw, car, or tor? So I've got opposite and I've got hypotenuse. So it's sine. So sine of 20 degrees, because I know the angle, equals opposite over hypotenuse. Now the unknown is at the top. So this is a more simpler example. When the unknown is at the bottom, we got to go 2 steps. Multiply and then divide. This one we just multiplying by 17. And I can even keep x on the right hand side. Just type 17 sine on your calculator 20 and equals. 17 sine, close the bracket, then press equals. 5.81 centimeters will be x. Alright, now you're going to try the next 4 questions. See if you can try the next 4 questions. The first one, I want you to find theta. Question number 2, I want you to calculate the unknown value, given that the angle is 40 degrees. The third question, I want you to calculate the unknown side over here, given that this is 6 meters and this is 10 degrees. And the fourth question, I want you to calculate, this is given as 70 degrees. This is 15 meters. And I want you to use those two and calculate this length here, which I'm going to call R. Okay, so question number 2, find x, find y. Question 4, find R. Try it. When you're done, we'll go through it. Press pause and then give it a go. When you're done, we'll go through it. Alright, let's go through each and every one of these ones now. In the first one here, we're going to choose saw, car, tor. So we got opposite and hypotenuse. So we're going to use saw. Sine theta equals 14 over 19. Moving sine over to the other side becomes shift sine 14 over 19. Run a calculator, shift sine, fraction button 14 over 19, comes to 47.46 degrees. Question number 2, we've got opposite and adjacent, so we're going to use tor. So tan 40 equals 50 over x. unknown is at the bottom. So we multiply by x, and then we divide by 10. 50 divided by 10, 40, comes to 59.6. To find y, for this one, you get opposite and adjacent. We use 2 again. So we use 10 again. 10 of 10 equals y over 6. The unknown is at the top. So we'll just move it across. Y equals 6 tan 10. 6 tan 10. That comes to 1.06. Then I have opposite and hypotenuse. This is going to be so with O and H. So sine of 70 equals 15 over r. The unknown is at the bottom again. Move the r to the left-hand side, multiplying both sides. Divide by the sine 70, leaving r alone on the left-hand side. Put that on the calculator. 15 over sine 70 comes to 15.9, which is about 16 meters. With 3 significant figures, which actually ends up to 16. Alright, so mark allocation here, getting a mark there, getting a mark for the angle as well. With the unknown side, you could possibly get a mark, 2 marks for working out, and 1 mark for the actual answer, and then 2 marks over here. Alright, let's look at a question now where you've got to use one triangle to get information so that you can find another triangle's problem. So basically, I'm going to have 2 triangles here. This is triangle ABC. That's my 90 degrees, and this is D. So that's triangle BCD. Let's suppose this is given as 40 degrees. And I know this is 10 meters in length. And I know that this is 50 meters in length. And I'm asked to find theta over here. So the question says find theta. Give it a try, think about it carefully. How would I end up finding theta? Think about 2 triangles. And then, yeah, when you're ready, type ready and I'll go for it. But try it. Think about sine, cosine, tan, using it twice for each triangle. Give it a go. Press pause and then try it. Alright, let's go through this example and then I'll send the link through. Okay. So the first thing I'm going to do is I'm going to look at this triangle over here. So let's start over here. So in triangle ABC, I can see that my opposite side is equal to BC, and that's what I want to find. Because if I can find this length, BC, I can use BC and CD to get theta. So in triangle ABC, I have this unknown side over here. I'm going to call it X. I've got 30 and I've got 40 degrees. So this is going to be opposite and hypotenuse. So I'm going to use so. So sine of 40 will equal x over 30. Multiply both sides by 30 and you'll get 30 sine 40 equals x. Put it on the calculator. 30 sine 40 will come to 19.3. So x will equal 19.3, not degrees, meters, right? Meters. So now I know this is 19.3 meters. Now I'm going to look at this triangle over here. Looking at that triangle, if I redraw it over here, I've got 19.3 and I've got 10 and I've got theta. This is my opposite side and this is my adjacent side, so I'm going to use TOR. So tan of theta will equal 19.3 over 10. Remember, to find an angle, we always use shift. So 19.3 divided by 10 will get me my final answer. With a calculator, press shift tan, fraction button, 19.3 divided by 10. And that comes to 62.6 degrees. Whereas x over here is 19.3 meters.